In order to solve a system using the elimination or combination method, both equations need to be written in standard form. And standard form looks like this: ax plus by equals c. So this form looks like, some number times x plus some number times y is equal to some other number. Now, to use the elimination, or it's also called the combination method, something else has to be true about the equations. The coefficients are just numbers in front of x or y. So again, to use elimination, the coefficients, or numbers in front of x or y, need to be the same, or they need to be opposites. Then, to use elimination, you will need to either subtract or add the equations to eliminate one variable, x or y. We'll start with an example where you're going to subtract the equations to eliminate. So if we look at this system of equations, we can see that both equations are written in that standard form: ax plus by equals c. Also, you'll notice that the coefficients of x, the numbers in front of the x's in both equations, those numbers are exactly the same. They're both positive 3. When we have the coefficients in front of one of our variables exactly the same, what we're going to do is actually subtract the bottom equation from the top equation. And I'm actually going to subtract just straight down because my like terms are all lined up. So 3x minus 3x, well, that's just 0, or the 3x and 3x are eliminated. Then we subtract again. We have negative 6y minus 8y, and negative 6 minus 8 is negative 14y. And finally, we subtract here at the end. Negative 36 minus 34. And negative 36 minus 34 is negative 70. And it's just fine to use a calculator as you're working on these, especially if the numbers get large. And now we can easily solve for y by just dividing both sides by negative 14. Negative 14y divided by negative 14, well, that's just y. And then negative 70 divided by negative 14 is a positive 5. So now we have the first half of our answer of y equals 5. Just like with the substitution method, to find the second half of our answer, we're going to use one of our original equations. It doesn't matter which one you use at all, and we're going to use the answer that we found. I think I'll just use the first equation again. So I'm going to rewrite this first equation, but include the fact that we now know that y equals 5. So I'll write 3x minus 6 times 5 equals negative 36. I will multiply to make the equation simpler. 3x minus 30 equals negative 36. And now I'll solve the equation, adding 30 to each side, giving me 3x equals negative 6, and then dividing each side by 3 to give me an answer of x equals negative 2. So the final answer is the coordinate pair negative 2, 5.